On the Venn diagram, shade the set A union B, but not. So that means it's not anything in this bit here. So it's definitely not that bit or that bit. So all of that is a big no. So we'll get rid of that. But it does say intersection with C. So it must mean this bit here. So basically ignore that bit. All that bit's wrong, so we're shading this bit here. It's not beautifully shaded, is it? But there we go. That'll do. Now, what on earth does that mean? So it means use set notation to describe the shaded region in the Venn diagram below. Okay, so the bit that's in, it's an intersection of some sort. So it's going to be this bit, and the last bit's going to be F, because it's intersecting with F, but it's not just E that's intersecting with F. So if it was E intersecting with F, that would be just this bit here. Okay, and we know that that's not what it is. So if it was just D intersecting with F, that would be that bit. And that's not it either. So that would be, so it's not D intersecting F, it's not E intersecting F, it will be D and E intersecting with F. And that's going to be, so it's due, though we're not, that's not really a U, intersecting with F. So the union of D and E forms an intersection with F. Hey, Barney goes to college. Good for Barney. He either goes by bus or he walks. The probability Barney will go to college by bus on any day is 0.3. When Barney goes to college by bus, the probability is late is 0.2. When he walks to college, the probability is late is 0.1. I think this is trying to convince us all to walk. Very good. Okay, so that means the chance of him walking is 0.7 because that adds up to 1. Chance of him being late if he's taken the bus is 0.2, and so the chance of not late is 0.8, 0.1 of being late and not late. He's slightly less likely to be late if he walks. Barney will go to college on 200 days next year. Work out the estimate of the number of days Barney will be late for college. So what we're looking at is we're looking at which days and like how he can be late. So he can be late. He goes by bus, he can be late using this. So it's that one. And then he can be late if he walks, he does that. So what we're going to be looking at before we times out by that is what the chances of him being late at all are. So it's 0.3 times 0.2 plus 0.7 times 0.1. And that means he's got very little chance of being late. So it's 0.06 plus 0.07, which equals 0.13. So he's got 13% chance of being late on any day. And that's 0.13 times 200, which I'm assuming is 26, but I'm going to take a chance anyway and have a look at times 200. You can always have a calculator in these. So he's likely to be late 26 days next week. Yeah, gosh, I don't think that's worth full marks. I wonder if I've missed something. Now, good, a straight line has the equation 2y equals 6x minus 5. The straight line L2 is perpendicular to L1 and passes through 9 minus 1. Give an equation for L2 and give your answer in this form. So before we start, in order to find out, I'm going to put L1 into the format of y equals mx plus c, because it's easier to deal with, because that way we know what m, which is the gradient, is, where it crosses the the y-axis with c. So that means 2y equals 6x minus 5. Let's divide everything by 2. And we get y equals 6 divided by 2, which is 3x minus 5 over 3. Now, L2 is perpendicular. Now, if something is perpendicular, it's at a T shape. So this one here goes like that. And L2 is going to be coming in like that. So this is L1, and this is L2. So it means, so a right angle, it means L2 is negative, but it's also the negative reciprocal of 3x. So that means that L2 is y equals minus a third x plus c. Now, in order to find out the point which it passes through the y-axis, we're going to have to put in the 9 and the minus 1. So we know that minus 1, which is the y, and that's x, equals minus 1/3 times 9 plus c. So that's minus 1 equals, that's 9 over 3, that's minus 3 plus c. So add 3 to both sides and we get 2 equals c. So that means we now know that, I'll just add this in, so y equals minus a third x plus 2. So let's times everything by 3, so 3y equals minus x plus 6. And then I've got to put the x onto the other side, so 3y plus x equals 6, and that's the answer there, because you have to rearrange it to look like that. Okay. A particle is moving along a straight line, and the fixed point O lies on the line. At time t seconds, the displacement is s meters away. At a time t seconds, the velocity of p is v meters per second. Find an expression for v in terms of t. Okay, so in order to get the answer, and you can kind of see what you have to do ds by dt. So you're going to actually have to differentiate this to find out what the velocity is. So ds by dt, which is the change in displacement by the change in time, is 12t squared minus 12t plus 5, and that equals, so v equals that in meters per second, if you see what I mean. By the time at which the acceleration of the particle is find the time at which the acceleration of the particle is 6 meters per second squared. We're going to have to differentiate it again. So ds d2 equals, so that would be 24t minus 12. And 24t minus 12, we've got to find the time when it equals 6. So this is the acceleration. Acceleration. I really am very good at spelling, but not today. So 6 equals 24t minus 12, so 18. Yeah, add 12 onto both sides. 18 equals 24t, so t equals 18 over 24. So that means the time would be 0.75 seconds is when the acceleration is 6 meters per second squared. And that can go here. I'm going to stop for a minute and